technology is not new. In fact, early applications date back as far as the 1940s. But of course, we're here discussing it tonight, and of course, it's been in the public's attention over the past 15 years or so, thanks to the shale gas revolution. The shale gas revolution has seen rapid upscaling of unconventional oil and gas drilling throughout the nation. Today, there are more than 23,000 active unconventional wells in the United States, and nearly half of those are present here in Pennsylvania. The debate around fracking will be not new to anyone in this room. Of course, on the one hand, we talk about advantages, economic opportunities, job opportunities, often in localized economies in rural parts of the state that have no ready alternative industry. Even at the national level, often increased national security, thanks to energy independence, has been attributed to unconventional drilling, in part. We must, of course, balance these advantages with potential disadvantages. Indeed, there are immense drawbacks, including adverse human health impacts and environmental degradation. And of course, this is all situated within the context of global climate change and our continued usage of fossil fuels and their contribution to global warming. Fracking is an example of a technology. Fracking is an example of a technology that got out fairly quickly ahead of the scientific and the public's understanding. So how can we possibly be expected to weigh these advantages and disadvantages? How can we create a space where, of course, there's distrust between the multi-varied stakeholders involved here? And where does the role of the scientists lie in all of this? Here to help us begin to answer those questions this evening is Dr. Susan Brantly. Dr. Brantley is the Distinguished Professor of Geosciences at the Pennsylvania State University and directs the Shale Network, a citizen science group that intends not only to better characterize the impact of hydraulic fracturing on groundwater resources, but also attempts to create these safe spaces for dialogue to emerge, for meaningful dialogue to emerge, which is a grand challenge here. Please help me welcome Dr. Brantley to the stage.
Well, thank you, and thank you for coming out. Like she said, it's a beautiful evening out there, I think. It was when I came in, and it's nice to see that you were able to come here. I just want to say, I was supposed to meet her at the business entrance, and I met her upstairs, and I stood in the Franklin Hall when the light show went on, and what a beautiful place this is. And I think a museum is not just the people that put it together, but it's the people that participated, and my hat is off to you. So I'm going to talk to you about what we've been doing with the Shale Network, and to really give you a sense of what it's like in rural Pennsylvania, because I know I'm here in Philadelphia. Rural Pennsylvania, as you know, hopefully, is beautiful. And there are many parts of it that are still beautiful. In fact, this is a farm where there is a small well that has been hydraulically fractured. You're used to pictures that look more like this. Here's another example of a Pennsylvania farm with the well pad in front of it. And the reason that we're here, and the reason I think you've thought about fracking at all, is because of the really fast implementation of this technology. The first shale gas well that was fracked with the new type of hydraulic fracturing was fracked in 2004. So that's where we are right there with the red dots. And you can see how fast the wells were put in place once they started figuring out how to do this. And right now in these 3 states, there's almost 18,000 wells, which we typically call either a shale gas well or an unconventional well. It's called unconventional because it taps into an unconventional reservoir. It goes into the shale instead of something like a sandstone. And a shale has such a small amount of porosity, holes in it, and permeability that it has to be fractured to get the gas out. And during this time period from 2004 till today, there have not only been a huge number of changes in the number of shale gas wells, but also in the techniques that have been used. This is an image from Range Resources, which is one of the bigger companies that's using these technologies today. And the lower picture shows the first well pad, and you can see that it is very ripe for a lot of erosion. It doesn't have a lot of liners. And then the upper well pad shows you that there's been a lot of change, a lot of implementation of better practices. The earlier well pads looked something like this once they were completed. Typically, there might only be one well on it, and now today, they are now putting well pads up that can have as many as 40 wells on them. And they're drilling down into the Marcellus Shale, and they're drilling down into the Utica Shale, and multiple wells, and you see a lot more of the infrastructure at the surface. This is especially in the western part of the state. This is sort of the canonical picture that you've seen. This is when the drilling is actually going on. So this is the drill rig, and there are drill rigs in the state right now. I just saw one when I was driving from the Adirondacks down to my home just last weekend. This is only in place for about 2 weeks, and then after that comes the hydraulic fracturing. And this is what they're doing. The innovations that allowed the shale gas revolution to happen were twofold. One part of it was a better ability to drill horizontally. So you can see the drilling has gone vertically and then has gone horizontally. And that horizontal drilling is part of what has improved and allowed us to get this shale gas out. So what they do is they drill down to the shale, and then they do the drilling horizontally along the shale. And that's the horizontal part that gets the gas out. And it always, or it's supposed to be always done thousands of feet deeper than the drinking water at the top. We pretty much drink water here in Pennsylvania out of the top couple hundred meters, and then there's thousands of feet down to the gas wells. It's very hard to get a sense of this. On one side here, this is a picture. You can go on Google Earth and look at Pennsylvania, and you can see the well pads. If you go on Google Earth and do satellite view and go up into the part where the drilling is, go to Bradford County or Washington County, and go in closer and closer, you'll start to pick out these rectangular well pads, and that's what you're looking at. And I tried to find a map that showed the vertical wells underneath the ground, a map of it from the engineers. I couldn't find one for Pennsylvania. So the picture on the other side is actually from the National Geographic. They did an excellent piece on fracking. This is from out in North Dakota with a different shale. And all those little black dots are the wells. So the well pads here are the sort of taupe-colored rectangles. The black dots here are the wells. And then you can see, hopefully, the little lines, and that's the vertical spread. So it's amazing what the engineers are doing in terms of being able to get those wells out into that shale to get the shale gas. And then sometimes they're at multiple depths. They'd be at one shale, and then if you had a map, you could show it at the lower shale. And then this is what it looks like on a well pad when they're fracking. They bring in millions of gallons of water. They used to use like about 4 million gallons for one well, but now because they're doing multiple wells, they can use up to 40 million gallons to frack all the different wells on a well pad. And it's done with computers. They have these things called frack shacks, and you go in there and they've got all the computers. Sometimes the fracking is controlled from Pittsburgh, not even at the well pad. But what you heard about is some of the problems, and I thought I'd just show you a couple pictures. This is our beautiful Pine Creek Canyon. If you've never been there, it's a gorgeous spot in Lycoming County. There have been various incidents, even in places as beautiful as Pine Creek Canyon. All along the ridges above Pine Creek are drilling. And this was an example where they were using a foam to drill actually a couple thousand feet away, and it ended up coming out in a spring, and they kept it from actually going into the creek. It's an organic compound, which I've labeled up there. And it got into the popular press. It became, a cause celeb. Movie stars got involved. Movies were made about it. You've heard about it. You've read about it. And I think it's really interesting that, what happened in our state in my opinion, became sort of a worldwide controversy and really led to the moratoria in other states and in other countries, as I've listed up there. So in 2011, I'm a geologist. I work with water and rock. That's my specialty. I started asking myself, what could I do? What do we need to do in the state? And so I wrote a proposal to the National Science Foundation, and we hypothesized that if we could share data and place it publicly online for water quality, and if we could bring people together to talk about it, then we could actually help with this conversation. And we were funded to do that. And it really started us on this partly citizen science, partly academic science project that goes on to this day. And the other partners on the project that got funding were University of Pittsburgh, Dickinson College, and then also a group of hydrologists that's called Quasi. And today we've got all sorts of people that are partnering with us. Binghamton University, the DEP works with us quite a bit, the Forest Service, and then several volunteer groups as well. And we've been putting data into the database, and this is just a number of data values versus time, and then those are the locations. We've focused mostly on Pennsylvania, but we work in some of the ancillary states as well. We're above 1 million data points and I think about 30 or 40,000 sites. And we always include data from academic groups, government groups, watershed groups, and companies as well. And we do different things with the data. We teach about it, we plot it, we think about it. As I said, I'm a research scientist, so I've always been trying to look to see what's causing problems when they're happening. And then sometimes we look at problems to see, is it really a problem or was it really caused naturally? So one of the things you've heard about is that natural gas sometimes gets into the drinking water, gets into groundwater. And so one of the big controversies has been, especially in Pennsylvania, when there is natural gas in somebody's drinking water well, was it naturally there or was it caused by drilling nearby? So this is a figure that we made for an article that was published in Science. The size of the symbol is the concentration of methane in the groundwater or in a stream, because some of these data are in a stream. And the color tells you who the data provider were. So some of the data came from watershed groups, some came from government, some of it came from companies. And this is an example of what we're trying to do, where we're putting the data together to talk about and to try to understand. And we spent a lot of time trying to understand what causes the methane, whether it is caused naturally or whether it's by some kinds of drilling problems. Mostly it's natural because it's very common to have natural gas in water, especially in Pennsylvania. But there are definitely cases that we've looked at that have been related to the development of the shale gas. So the biggest provider of data to us is the Department of Environmental Protection. And that data comes from companies, from gas companies. So when the gas companies want to drill, they go out and sample water ahead of time because they're convinced that when someone complains that there's gas in their water, they're convinced, the companies typically are convinced that it was there beforehand. So they go out ahead of time to get the data to see, is there truly gas in the water beforehand? Well, that data has been collecting at the Department of Environmental Protection because the companies give it to them to safeguard them against liability. And the DEP hasn't been able to put it out for the public because it has personal information on it. It has the homeowners' names and their address and that sort of thing. So we said, well, why don't you give us the data? We'll strip the names out of it and the housing, the addresses, and we'll publish it publicly for people to look at. And it took about a year to get an agreement between the Department of Environmental Protection and Penn State. So between the state of Pennsylvania and Penn State, it took about a year for the lawyers to work it out. But now they're giving us data, and I pay students to put it online. So now we have probably more groundwater data for Pennsylvania than any other state that's published. The chemistry of it is published online. And one of the states we focused on is Bradford County, which is up in the northeast, because that's one of the centers of the drilling. And there's, I think, there's 11,000 data points in this particular graph. But we also started finding that no matter how much we looked at stream water chemistry and how much we looked at groundwater chemistry, the groundwater chemistry, spatially we have a lot of it, but we only have the one data point that the companies went out to collect it. So you have one time point and a lot of spatial points. Streams, we might have many points at a given time points at a given place, but we don't have a lot of places being sampled for streams because that's very time consuming. And we have something like 10,000 kilometers of streams. So we very quickly realized we're never going to have enough data to be able to really monitor for these problems. We're never going to be able to have enough time and spatial coverage to really see all the problems. And so what are we going to do about that? And we decided that we really had to create conversations, so we started to run this workshop every year. And these just show you some of the pictures. This is the workshop that happened just in May. And you can see someone from Shell Oil talking to a graduate student from Pitt about her poster, where she was looking at all the violations that are online throughout Pennsylvania and talking about it. And then we always do field trips, and the field trip picture is we went to a landfill, because this is something that most people don't know about, but not only when you drill is there problems with the water that comes back up, and I'll talk about that in a minute, but there's also shale that comes back up, and we call those shale cuttings. And so like 1,000 tons of shale cutting for each well, and those all have to be disposed of. And so we're putting them in our municipal landfills that are permitted to take this kind of thing. Watched what they were doing with the shale cuttings and talked to them about what's happening. And because the workshop participants were interested in studying it. The other part of our field trip was we went to a place where they treat water. I mentioned the water. When you drill for gas, not only does gas come up to the surface that you can sell, but water also comes up. And this comes up whether it's an oil well or well, very salty. And in this state, water is 10 times saltier than seawater. And this brine, very salty water, has to be disposed of. Should I use the hand mic? And the way it's disposed of mostly in Pennsylvania is very innovative. This is the only state where almost 95% of that water that comes back is now re-injected for hydraulic fracturing, which is the best thing you could do with it because it's sending it back down thousands of feet down. Some of the water has to be disposed of in injection wells, and so early on we hadn't figured out how to pump it back down to use it for hydraulic fracturing. It was trucked to an injection well or one of many injection wells in Ohio, or sometimes it's taken to some treatment plants. There's a small number of treatment plants. This is one that's in Williamsport, right in the center of the state, where they try to separate out the salt from the water so that they have relatively clean water, and then the salt can then be taken to a landfill. The picture on the side with the green is another one of our field trips at our workshops. Every year we do a field trip, a different type. What we did there was a mock spill. That green dye is a biodegradable dye that hydrologists use to study what happens in terms of mixing in rivers and that sort of thing. We had the DEP come and all of the participants come, and then we did the spill, and then the DEP showed us what they do when there is such a spill, and how they take care of it. So the other thing that happens at these workshops is we talk about different incidents. And one of the years, back in 2014, we heard about an incident up again in Bradford County. This was a place where a homeowner saw methane in their groundwater, and then they started seeing foam in their groundwater, and you already know what that is because I showed you the foam at Pine Creek, but at this time nobody knew what it was. And so because we'd learned about this from someone at our workshop, we went out there, we analyzed it with Frank Dorman, a chemist at Penn State, and then that's when we figured out that it was the 2-butoxyethanol, which was this drilling agent, this air foam. And it was moving 2.5 kilometers from the shale gas well to the drinking water wells. So you can see the little black dots where the shale gas wells were, and you can see how far they moved to get into that drinking water well. The other thing that we learned by working at that site is that we learned something about the geology, and the red line on that picture shows you where a fault is coming to the surface. And so hopefully you can see where the rocks have moved along that fault line. And it turns out that that fault was probably the conduit that was allowing the movement to occur. And so we ended up thinking quite a bit about the sort of folds and faults that we can see in Pennsylvania. And this just sort of shows it to you, what you might see from an airplane flying over Bradford or Lycoming County. You see the anticlines and synclines, which is just the geological word for the folds and faults. And then where faults are actually mapped. And we're starting to be able to use this geological information to understand why problems occur in Pennsylvania and where they occur. And so when we take our groundwater data, which I already showed you for Bradford County, and then we use some new kind of data mining tools, some of these new data analytics, and try to look at the methane concentrations, the natural gas in those different groundwater data points, and ask whether they increase or decrease when you move towards certain features like a natural gas well, or in this case, this is a shale gas well. What we see is that these dark spots on this map here show you that as you move to the dark spots, the homeowners' water wells get more and more natural gas. And we think that it's related to some problematic shale gas wells, in those particular zones. And that they're related to the folds and faults that I was mentioning to you. At another workshop, we learned about another situation. This is again in central Pennsylvania. You can see the fold in the block diagram. You can see the closest shale gas well. We don't know what shale gas well is problematic, but that's the closest one. And then about a kilometer away, methane has been coming up in a stream, and you can see where it's coming up in the brown. It looks a little bit like acid mine drainage if you've ever seen it, but it's really just bubbling methane that's coming up with some iron. And we were able to relate that also to the geologic features as well. So because we were starting to see methane coming up into streams, we started realizing, well, one thing that we could do with citizens around Pennsylvania is actually sample stream water with them. It's hard to sample groundwater. You got to get into somebody's house and get permission. So we started working on stream chemistry, because you can see the natural gas coming up into streams as easily as into the groundwater. So we aligned with Trout Unlimited, and we started running watershed snapshot days where we work with a watershed group, and we get 50 people to go out on one day and sample all around the stream. And these pictures are with my grad student, Josh Rhoda, who's at the center up in Allegheny National Forest. And we've run a couple snapshot days up there, and you can see some of the volunteers that come out. And this is a picture in the Allegheny National Forest. As you may know, some of the oldest oil wells in the country are up there in northeast or northwest PA. The very first commercial oil well is 1859. And all around the Allegheny National Forest, you can find very old conventional wells and then some abandoned wells like the picture on the left. You can actually see the gas coming out. And this is my postdoc out there sampling. What they were trying to do is see which of these wells were leaking and which of them actually have natural gas coming out. So as we worked on this, we learned more and more about Pennsylvania, and we've been helping the citizen scientists learn about it. There may be 500,000 oil and gas wells in Pennsylvania. Most of these are what we call the conventional oil and gas wells, and you can see them. The green ones are the conventionals. The gray dots are these new shale gas wells. And there are so many wells that we don't even really know where many of them are. And they're not mapped. The DEP doesn't know where they are. One of the great things about working with volunteers is that they often know what's in their landscape. And you can see a gas well here, and we wouldn't have known about this except for that the volunteers took us out there into their into their surrounds where they knew where these wells were. It's not just oil and gas wells that are leaking natural gas. Coal also has natural gas. And we also, as you know, have coal mines all over Pennsylvania mapped up here. There are also coal mines that we don't even know where they are. And the coal mines give off a very large amount of natural gas. This is just a picture of one adit where there's water and natural gas coming out. And my colleagues at Penn State, the meteorologists that fly over the state and measure natural gas emissions, say that the biggest emissions in the state are from the southwest where there's these old coal mines. So as we learn more about this and the people that came to our workshops became interested, this last year we brought in some of the coal mines and the gas companies to talk about the sort of juxtaposition, the overlay of shale gas development with the coal mining. And this was a conversation that was absolutely fascinating because I had no idea, but they're now drilling through coal mines to get to the shale gas below in the southwestern part of Pennsylvania. And there's a lot of technology and regulation that they're working on nonstop. And so we had 6 people from some of the companies that are doing this drilling actually talking about how they model it and how they figure out the drilling that they can do. And I think we'll keep doing that. So this is my last slide. The workshop every year ends with a conversation where we ask the participants what do they want to talk about next year. And then we try to find people and move in whatever direction the participants want to go. So we've had people talk about shale gas and human health, about atmospheric emissions. We started talking about the ethane cracker plant, which is the picture over here. One of the things that you may have heard about is a lot of the western part of the state, the gas that comes up, it's not just gas and it's not just salty water, it's also long chain hydrocarbons, ethane, propane, butane, so the liquids, wet gas. And those are very useful economically. They use the ethane, they crack it and make ethylene, and that's what the plastics industry is built on. So they're now building an ethylene cracker plant just outside of Pittsburgh to be able to start a plastics industry. So we had people come and talk about that. And because they need the ethane, they need a place to store the ethane. And we had someone come and talk about how they're going to store the ethane. And what they're talking about is using reservoirs either in southwest Pennsylvania or West Virginia, where they're going to, the ethane comes up with the natural gas, and then they're going to pump it back into the reservoir to hold it until it can be cracked to make into plastics. And so, what I'm trying to give you a sense of is sort of the complexity of this whole thing, and that's what we've been trying to do in terms of our workshops, is to be able to talk about, the whole trajectory of what's happening with this industry. And we've had economists come. We've never talked about pipelines, but I think that'll come up in one of the next few years because there's also a lot of interest in that. So that's what I wanted to tell you about, and I appreciate the opportunity to talk about both the science or the side of outreach and getting the dialogues to happen. It's probably the funnest thing that I do, is to get this workshop to happen, because the conversations that happen are, every single person that comes, the gas company folks, they love being there. The watershed groups really like the interaction. The DEP has absolutely loved it. The Department of Environmental Protection has absolutely loved it because they feel like they're getting opportunities to work with people that they've never really had before. And they're working very hard on this particular problem. So thank you. So who's going to get the microphone?
We'll pass back. I have 2. Wonderful. Thank you, Sue. If you'd like to submit questions, please do so by emailing speakerseries@fi.edu, or you can tweet at us at #TalkFI. Sue, I'm glad you ended there with a note on the complexity of this issue. I think one thing that I struggle with as an environmental scientist being in an urban setting is that we're physically removed from so many of the complexities that you addressed here. I'd like to delve in a little bit, actually, to start with some term definitions to help us unpack some of that complexity. There was some technical language in there, and I just want to make sure we're all up to speed on it. So we started with the term reservoir. Could you clarify for us reservoir?
So when we talk about a reservoir, it's the rock in the subsurface that holds the natural gas or the oil. I kind of brushed over this, but since 1859, when the first commercial oil well was drilled in Titusville, Pennsylvania, we've really been drilling into rocks that have a lot of holes in them and that contain oil or gas. But that rock typically wasn't where the oil or gas formed. Usually the oil or gas forms in a shale, and it moves from the shale to a rock that has a lot of space in it, a lot of holes in it. And that's easy to get out, or easier to get out. So we drill the reservoir that's easy to get it out. What's really changed is we're now going back to where the oil or gas forms, and we're getting it from the original rock, the shale. And that's considered an unconventional reservoir because we knew it was there. We've known for a really long time that shales have oil and gas, but we didn't know how to get it out because it was stuck in there because the permeability was so low. And permeability just means, how easy it is for a liquid to flow through the rock.
So therein lies the difference between conventional and unconventional drilling. Fantastic. You actually covered several of my terms, so I think we'll move on. I was surprised at the conversations that have emerged in the Shale Network, how in several instances we've found pollutants that otherwise it seems a baseline groundwater monitoring system would not catch, or perhaps we don't sort of have a baseline groundwater monitoring system. Could you talk a little bit about that? What maybe state regulations, are there requirements statewide or in other states that help us, or rather require that type of monitoring, and how would we do it?
Well, first of all, let me say I think 40% of Pennsylvanians drink well water, and we don't have any regulations about well water. I can't remember exactly the percent, but a relatively high percent of the drinking water in wells in Pennsylvania that people are drinking would fail regulations in other states. I forget exactly what it is, but it's like 40% or something. It's relatively high. So there isn't really any monitoring of that drinking water reservoir. And most people, before this started happening, most people weren't getting their water analyzed. And one of the big messages that people have been trying to get out to Pennsylvanians is to get their water analyzed. But it costs money to get it analyzed, and it can be pretty expensive. Sometimes I like to emphasize that, this is a little bit of a sardonic twist on it, but it's almost a gift from the gas and oil companies that we're getting all this groundwater data. I mean, we have a huge amount of groundwater data now that we didn't have before because they're going out and measuring it, and we should be protecting our groundwater. Now, another piece of what you asked about was, all these different compounds. I didn't really talk about this, but the first thing I think that most people are worried about with fracking fluids and the fracking technology is all the toxic compounds that are used in these fracking fluids. So what they're doing to get the fractures to happen is they're pumping water down at high pressure. And it's such high pressure that the rock fractures. And that then allows the gas that's trapped in all those little pores to move back into the borehole and come back up to the surface. So that costs money to make that pressure. They're pumping down miles in the subsurface and miles out. That's another thing. The length of these boreholes, the horizontal boreholes, is getting longer and longer because the technology is getting better and better. But that costs a lot of money because it's high pressure and they've got to pump it. So that's costing them money. So they put all sorts of chemicals in there to make the fracturing easier. So they put acid in there because that helps dissolve the rock, and if you can dissolve it, it'll help it fracture. They put biocides in there because they don't want bacteria to grow anywhere along the line and plug it up, because when bacteria grow, they plug things up. They put gel in there because they not only want to fracture, but they want to prop the fractures open. So, it's such high pressure at depth that once they open the fracture, it would close right back up when the pressure went down. So they have sand that goes in the high pressure water that holds the fractures open. So to move that sand miles into the subsurface, they put gels in that hold the sand in place. But then they have to break apart the gel because they want the gas to be able to come back out. So they have gels, and then they have stuff that changes the gel properties. Anyway, there's a lot of different compounds, and some of those are toxic. And we're not analyzing for those. It's difficult to analyze for those. When we looked at that foam to try to figure out what it was, we used an unusual instrumentation that most commercial laboratories don't have. And so it can be very difficult to look for all these different compounds, and we're not really monitoring for them.
Glad you touched on that in preparing for this talk. Having some analytical experience myself, I thought about the array of technologies that we use in a lab setting to understand a mineral composition, for example. And once we start talking about biocompounds, forget it. So towards that end, on the instrumental necessities here, how do we even begin? It's not as if we can, for example, take a gallon of water and send it off to the lab, and all of a sudden we understand all biological and mineralogical factors. So how do we narrow down those decisions? How do we go into that study to start, I suppose, to understand, should we be looking for a particular compound, et cetera?
Well, first of all, when the water comes back up, it will have some of the toxic compounds in it in the first, let's say, week or so, and that's when it's called flowback water. So they inject water and then it comes back up, and that's called flowback water. But after the first 2 weeks, the water that keeps coming back, and it comes back, as long as there's gas, then there's water coming back as well. It's then called production water, and by the time it's coming back, 2 weeks out, it doesn't have any of the toxic compounds in it to any measurable extent. So there's only a real short window when those toxic compounds are on the well pad, either stored in a tank, are being injected, or come back. And they're not used in super high concentrations, and so even when they come back up, they're not present in super high concentrations. What is present at high concentrations is salt. Mm-hmm. And so, one of the things that we do, if someone has a organic compound, which is what these toxics are typically, is organic compounds, in their water, and they think it's from, somehow from a local shale gas well, we'll look to see if there's salt present, because if it did come back up as flowback, there has to be salt there. There's so much more salt than there are these organic compounds. So, the salt is a much more likely contaminant than any of these organic compounds, because there's only a short period of time when their compounds are being used. But there are a lot of wells, and they are being moved around the state, so there is opportunity. The most common mechanism for these compounds to get into water is from spills. I don't know of any cases in Pennsylvania where fracking fluids went down and came back and got into anyone's drinking water, but there have been spills. Well, in Dimmick, first of all, it's very hard to get information about Dimmick, to get a lot of data about Dimmick, but most of the problem at Dimmick was natural gas that got into people's water wells. And of the 18 water wells that I know about that have been cited, I think 17 of them had methane in them, methane being natural gas. And it does look like it was there because of the shale gas drilling. I don't know of any information where there was fracking compounds in those water wells. Excuse me? I've been to Dimmick, yeah. I've sampled some water wells at Dimmick. I've sampled some streams at Dimmick. I haven't done a study at Dimmick. And Dimmick is up in northeastern PA. It's near Bradford, where I was showing you. And it's a difficult place to get access. A lot of there's been a lot of people descended on Dimmick. And people don't always like people descending on their homes and knocking on their doors and sampling their water and that sort of thing. So that's a difficult one to actually get a lot of data for. The two studies that I showed you, we were able to get access to a lot of data. And that's really what you need. I would love to get it for Dimmick. I would love to work on it on Dimmick. But you need a lot of data to be able to really, figure out what's going on.
And I'm glad that this came up. It sort of speaks to the need for a project like the Shale Network, right? And so in several of these projects that you listed, we knew to investigate those areas because of stories that partners in the Shale Network brought to conversations. Could you reflect a little bit on in general, when you work with community members that are impacted by shale drilling, what's their sentiment? I would imagine there's a range of responses.
Well, I think that in some cases it's heartbreaking. What I see in the data, first of all, we have a lot of data, but we don't have enough data. So what I think I see in the data is that the number of incidents that happen divided by the number of shale gas wells is relatively small, I think. I can't be completely confident because data are not always released publicly. And everybody in this room should be demanding that data be released publicly. That's the single thing that we most need. But everybody, almost every stakeholder resists, releasing data. Academics don't want to release data because they want to get their publication out first. It's true. Homeowners don't like to release data because they want to be able to sell their house. It's true. Gas companies don't want to release data because their lawyers don't want them to. DEP won't release data because they often don't have it organized really well because they're kind of short-handed, and also because there's personal information on it that has to be redacted, and they're short-handed to be able to redact it. I don't know who I've left out here, but in my experience, almost everybody resists releasing data. And especially for groundwater, groundwater moves. It's a public resource. I personally think that every groundwater analysis that's done, it should have to be released. Like, you should have to release all the groundwater data. I forgot where I was going with the question, but, about the homeowners. Okay, so, I wish I had more data. The only reason data don't get released is when it goes to litigation. Often, what happens when it goes to litigation is, after a long period of time, the homeowner finally says, okay, and maybe the gas company buys the house or gives them some money, and then the gas company says, okay, let's not release the data, and the homeowner agrees because they've lived through this really hard situation. So that data doesn't get released. We need that data. It's very rare, and we've published some of the only papers where the data have been released, and you can really go over and try to figure out what goes on. So I think the number of incidents divided by the shale gas wells and the amount of natural gas that's being produced is relatively small, but every single incident is a family, or a couple, or a person whose beautiful house in a, relatively rural or forested area of Pennsylvania, is now not the way they wanted it to be. And some of the places I've been have been gorgeous spots, just absolutely beautiful spots, but the, gas is coming up into their water, or that foam or whatever. So, it's something that society has to grapple with. I mean, these shale gas wells in Pennsylvania are producing more natural gas than any other well in the world. These are huge wells, absolutely huge wells, especially the new ones that are going down into the Utica where they've got, more than one well on a well pad. And the amount of gas that's being produced and the amount of money that's being made is enormous. And then once all the pipelines come over to the East Coast here to where you're using gas, and once they make the cracker plant, or once they make the plastics plant, it's a huge industry that's happening. And I think people have to really understand the enormity of the whole thing and how it all fits together. But it's difficult.
Sure. You mentioned there the difficulty and the trepidation that a lot of stakeholders felt sharing their data. But obviously, based on some plots you shared with us, there's been a measure of success. So how did you begin to build trust and create that space to have those open exchanges and to encourage folks to help you sample and to help share their experiences, both on the private and the public sector?
Well, I don't know. That's a good question. Sometimes I've asked myself, what is the secret? One thing I think is we really do emphasize talking about data at the workshop. I mean, we try to talk about observations, and we try to have all stakeholders represented. In the beginning, the hardest part was getting the gas company to come. In the beginning, we had, mostly watershed groups and academics, and then a little bit of representation from the Department of Environmental Protection, and none of the gas companies would even show up. So we worked really hard to get some of the gas companies to send people, and then we put people from each of those groups on our steering committee so that everybody can decide or have input about what the workshop is going to look like. And because of, all the representation on the steering committee, that means that we get different people. If we have someone come talk about health problems, we'll have some people from the gas company side come and talk about it from their point of view also. Another thing we do is we don't try to come to a consensus. We don't try to make a decision because we wouldn't agree. We have different opinions in the room. We just try to create dialogue, because the dialogue in itself is really helpful. And I've had people stand up in the room and say, I've never been in a meeting where the regulator's here, the gas company's here, the watershed groups are here, and the consultants are here, and we're all in the room talking. Sometimes it gets a little heated, and I've actually had to explain to the non-scientists in the room that you might see scientists, getting mad at each other and kind of getting a little heated, but that's what scientists do. But we really try to help the conversation happen. I mean, this year we had someone come who's from I think he would say he's from an advocacy group, and he was very hesitant to come. I think partly because I think Penn State, has a bit of a reputation, and he didn't understand what the workshop was going to look like, and he was going to be on a panel. And I said to him, total green light. You can say anything you want on this panel. Talk about what you know and what is true for you. And he ended up loving the workshop, and really feeling like the conversations that happened were great. And one of the things he was talking about is, just the enormity of the asymmetry between the companies and their knowledge and their lawyers and their scientists and the residents, and their sometimes lack of technical knowledge and lack of lawyers and lack of time, to organize. And he started advocating for funding from the gas companies for some kind of citizens, advisory group or some way to fund some help. It's a conversation.
So is it fair to say then that the Shale Network and you and other scientists working with this group, you're really the facilitators of that dialogue?
Yeah, I think so. We've always had good conversations. Sometimes it gets heated. This year it got a little heated. But I don't know that the heatedness is all bad, as long as everyone gets to talk and everyone gets to have a conversation. You asked about individuals. We've had a couple come, who has come practically every year, and they're a little bit older than I am, and they live up in a part of Pennsylvania where there's a company that wants to put in a well for injection of these brines. So this would be a well where brines would be trucked up there and then it would be injected in. And it's not that far from this couple's property, and they're very against it. And so they've been coming every year to really dig in to try to understand it. We had them on a panel, and they were on the panel with people from Tetra Tech, which is one of the companies that works with the water disposal. And they asked a lot of their questions, and they're working very hard on their particular situation, and they've become quite knowledgeable about it.
Sure. So I'd like to transition a bit. We have a lot of audience questions focusing on geologic impacts specifically. A popular question coming through is, can fracking lead to earthquakes? And I'll tack on there, can fracking lead to earthquakes specifically in Pennsylvania?
Yes. First of all, in many ways, you can think of a frac as an earthquake. It's an earthquake down there in the subsurface that's controlled by this high pressure that's being injected. But the fracking itself can cause an earthquake to occur in a different location than along that shale gas borehole where the fracking is occurring. And it has happened in Pennsylvania. It's also happened in Ohio. And it typically, interestingly enough, at least to a geologist it's interesting, we're fracking the shale. Beneath the shale and these sedimentary rocks is what we call the crystalline rock, the basement rock, the older rock. And there are faults down there in the basement rocks. Usually the earthquakes happen in the basement rocks. And that's what happens down in Oklahoma also, where they've had lots and lots of earthquakes because of the fracking. Actually, I'm conflating two things, though. Let me step back. The earthquakes that happen because of the fracking are very uncommon, but that does happen. Most of the earthquakes that happen are not related to the fracking. It's when they pump the brine down into the injection wells. So I was conflating those two things, which most people do. They conflate them, and I shouldn't have done that. But you can have earthquakes related to the fracking itself, but most of the earthquakes that are related to the shale gas are when they inject brine down into a well, a disposal well, to get rid of it. And the earthquakes in Oklahoma have been largely related to the injection of the brines in the injection wells. Oh, and in Pennsylvania, I think there's only been one that was related to fracking, and the DEP immediately stopped the company from continuing the fracking. It was way over on the western boundary of Pennsylvania, very close to Ohio. And so there's something about the geology over there, because there have been some similar things happen over in Ohio as well. And because of this, the Pennsylvania state has decided to put seismometers out across the state. I think there's like 40 seismometers across the state. There's a really good seismological network now where they're measuring for earthquakes all the time. And because they've got all these seismometers, they can measure really, really small earthquakes. And interestingly enough, when they first got the seismic network out and started measuring it, and the person that's running this is my husband, so I know quite a bit about this. And he'll get mad at me for conflating those things, and I did. But he saw many, many earthquakes. And it was, like, wow, there's so many earthquakes. And then they started noticing they were all between 9 to 5. And what they were was the blasting in quarries and in coal mines. And, that's kind of interesting, too, because, just like when we started looking at water quality and started going out, the water quality issues around the older conventional wells, the really old ones in the coal mines, is much worse than the water quality impacts that we're seeing around these shale gas wells. So one of the things that's happening is people are going out because we're interested in the shale gas and what the impacts are, but it's also driving Pennsylvanians and scientists to start understanding, and looking again at some of the impacts that are in our state that have been here for a long time. There's a lot of coal mining going on.
I think that relates to another audience question about ground stability. Will drilling, and I'll add on, and fracking, affect ground stability in the way lowering of water tables in Florida led to the occasional sinkhole?
Well, I think that's possible. I don't know too much about that. I've never heard of a case that I can talk to you about. That's just not something I know too much about. I think when drilling is going on, there are times when water connections happen. And for example, up in Tioga County, I don't know if you've seen, there's a picture, if you Google it online, of what they call a methane geyser. And what it was they were drilling in one place, and somehow a connection was made to an old well that wasn't that far away. They knew about this old well, but this connection happened, which they don't completely understand because it was in the subsurface. Anyway, it blew up natural gas and methane somewhere else, and there's pictures of it up in Tioga County. So because of connections like that and the fact that high pressure can come out, that could certainly cause something like you're talking about with subsidence. But again, I know less about that.
Okay. And one last geology-specific question, though it's tough for me to leave the geology questions as a geologist myself. Are geological flaws the sole routes for contaminants to make their way to well water? Is simple diffusion through the rock not a factor?
Who asked that question?
Don't feel obligated to raise your hand.
Diffusion, is a way that contaminants can move through water, but it doesn't move very far. So diffusion is happening, but it doesn't move very far. If gas is moving any distance, it has to be moving through porous space, porous rock, or along a fault, or what we call bedding. So any kind of sedimentary rock typically has a layering to it. And what does that mean?
The person that asked the question.
So the layering in sedimentary rock opens up as the rock, anywhere near the surface, the bedding will open up. So there's typically lots and lots of places for the gas to move through the rock, and that is the more important pathway than diffusion. Like I'm in a light show or something. Now I know what Ben Franklin felt like up there in that light show.
Okay, I'd like to transition back to something you mentioned before we shared that slew of geology-related questions there. And it had to do with the network participants. And you mentioned that as of late, you've started talking about health impacts and started working with health researchers. Can you explain a little bit about what our understanding is around the health impacts of hydrofracking is?
So it's still early to understand that. There's something like 20 papers that have been published, and there have been many papers that have shown correlations between some health impact and some kind of data that's related to shale gas. So, for example, there's been several papers where people have looked at birth rate of babies born to mothers that were living in areas where shale gas is being developed. There's been papers about asthma. I think there's one paper, they looked at some cancer, but I haven't looked at that paper very carefully. It's still very early, and I don't quite know what to make of them. I've tried to get health data so that I could work with our data and with the health data. It's difficult to get access to health data, so we haven't been able to do that. We're starting to maybe get ability to do that. There is a lot of interest in this. The EPA has had a competition and has given a big grant to a group of people. I think they're in Yale and some other places, but there's a professor at Yale that got some of that money, and she's starting to look at the data. And then there's a sort of like an honest broker group, the Health Effects Institute, which is up in Boston, that has started looking at all this and is trying to help map out a path forward to do the research to really look at health impacts. And the Health Effects Institute is not funded by industry. It's not funded by anybody. It's like I said, it's kind of nonpartisan. They've looked at these papers that I'm talking about and have concluded that it's still too early to make any kind of conclusions. There's just different problems in different papers. Sometimes the data set isn't big enough. Sometimes the conflating factors haven't been separated. So, obviously if you're smoking, you're more likely to have certain kind of health effects. And then, if you're not separating that out, that can be a problem. So it's really thought that it's hard to draw any conclusions yet. And I think there's a lot of people that are trying to do that kind of work. I would like to say that it's difficult to get funding to do this kind of work. The National Science Foundation doesn't provide a lot of funding in this area. Department of Energy doesn't provide a lot of funding in this area. EPA doesn't provide a lot of funding in this area. People would love to be able to do more studies. You're starting to see more studies come out, but it's very difficult to get the funding needed to do really good studies. And, what data that have been published, the impacts that have been seen have been relatively small, and so we really do need good studies. If the effects are real small, it's going to be hard to pick them out and to do the work well, and so we need that kind of funding, and then we need those kinds of researchers to do the work.
Sure. So to add on to that then, what other information or types of data do you think are needed to better elucidate these health impacts? It sort of seems to me like there's a time variable here, but where can you contribute, and folks that are working in and around the Shale Network, where can you contribute to that health research?
Well, the studies that have been done have been regressions or correlations. So they look and they see, how many low birth weight babies are there and how many shale gas wells are there. And then they just see, do they correlate? Does the birth rate, the incidence of low birth weight babies increase as the number of shale gas wells increase? They also need to do studies to figure out if there are impacts, how it's happening, what is the mechanism, what is the pathway. And from my understanding of the water data, I just don't see a high enough incidence of problems that I can believe that it's getting into people through their water. There have been cases where the water was contaminated, absolutely, and then they stopped drinking the water. And I think there were problems early on that were litigated and that I don't have any data for. So I'm not denying that health impacts happen. I'm not denying that. I just don't have the data for that. But I think most people are starting to think that it may not be through the water if there are health impacts. It may be more related to emissions into the air. So, for example, there are emissions into the air of volatile organic compounds, at the well pads, at compressor stations, sort of pipeline connections, that kind of thing. I think people are wondering if there are health effects. Again, I don't have the data to say that there are, but if there are, I think people are starting to think it may not be the water, it may be air emissions. So I think we need air emission data, and then we need studies to try to figure out not only just correlations, but what is the pathway that it might have gotten into humans if there are health impacts. I mean, at the last workshop that we had, Jim Fadisak from University of Pittsburgh gave a talk where he's been looking at health data and comparing it to some organic compound air data that he has. And as the contaminants go up in concentration in the air, he doesn't see the incidence of low birth weight going up. This is preliminary, but he was talking about it at our workshop. So it didn't look like the air emissions in his study were causing any kind of low birth weight. But again, it's all too early, and we'll be seeing papers come out, but you should advocate for it. You should ask, government and different institutes to put money on the table so that the good studies can be done.
So lots of work to do for you and for us, it sounds. We're down to our last few minutes here, and I'd like to bring it back to an audience question that's asking about the future. What's the fate of natural gas drilling in Pennsylvania?
Well, one of the people that came and spoke this year was from the Energy Information Administration, EIA. And it's an agency that collects data. They don't make regulations, they don't do anything, they just collect data. And you can go online and find all sorts of information about oil, gas, coal, everything. And the data that he was showing about the well pads in Pennsylvania was just astounding. He was saying that the shale gas industry in the state is going to keep increasing. The amount of natural gas that is being harvested is going to keep increasing. And I think there's going to be a lot of pressure to maybe make another cracker plant. There's going to be pressure for more pipelines. I just think it's going to keep growing. That's what it looks like to me from what I've been learning about. We haven't talked about issues around methane getting into the air, and I want to say that methane in the air is a greenhouse gas, and it is a worse greenhouse gas than carbon dioxide, but only for a short period of time, for something like 25 years before it breaks down. But when we harvest natural gas, we lose some of it to the air, and then when we burn natural gas, CO2 goes into the air. So there's two opportunities for some greenhouse gas. The greenhouse gas implications are really worth thinking about also. It does really look like the amount of methane loss is relatively small, and it does look like burning natural gas is less of a problem from a greenhouse point of view than burning coal. There's been a lot of arguments about that, but the data is starting to look like the loss rate is small enough that it is a benefit to switch from coal to natural gas in terms of greenhouse gases. So I think that our state's going to keep producing this, and I think we need to worry about the greenhouse gas implications as well.
Thank you, Sue. We've covered a wide array of topics tonight, including a light show for all of you, especially this evening. Please help me join in thanking Sue with me for this evening's